Today I will be describing a prokaryotic replication fork. To begin, this molecule here is DNA helicase, and its job is to separate the hydrogen bonds, breaking the DNA into two strands. This green molecule here is DNA gyrase, and it'll move ahead of the replication fork, making sure to prevent any supercoiling that is occurring. So once the strands are separated, single-stranded binding proteins will come, and their job is to keep the DNA separated so it doesn't rebind to itself, and also to help protect and stabilize it. This dotted line through the middle is the origin of replication, and it's basically just where the DNA will start replicating. The top strand, the yellow strand here, is the leading strand, and it's called the leading strand because it can continuously replicate into the replication fork. This is because DNA polymerase III can only add to the 3' end, and DNA can only be replicated by adding to the 3' end. So, to do this, DNA polymerase III needs to start somewhere. So these blue lines here are primer laid down by RNA primase, and the DNA polymerase III will start there, and it'll continuously add on the top strand by creating phosphodiester bonds. On the bottom strand, however, the lagging strand, this red strand here, it can't continuously add. So what happens is the primer will be laid down, and then the DNA will be added the opposite direction, still in the 3' direction, and it'll just happen over and over again, so you get many Okazaki fragments. Now these need to be joined together, so DNA polymerase I will come along and remove the RNA primer. However, this leaves a nick in the DNA, and DNA ligase is what is going to come along and fill this nick. So you'll have a completed strand of DNA. Right, and that's all. Thank you.